AP workbook, J. A rocket fires its engines to launch straight up from rest with an upward acceleration of 5 meters per second squared for 10 seconds. After this time, the engine shuts off and the rocket freely falls straight down to the Earth's surface. So we're going to start by sketching a graph of acceleration as a function of time from 0 to 10 seconds. So we're just worrying about this first 10 seconds, right? So we're just looking at while it's accelerating at 5 meters per second squared. So let me just fix this printout because it didn't show my axes. So for those 10 seconds, this acceleration is a constant 5, does not change. Oops, should end there. Then it says to sketch the velocity versus time graph for that time period. So the area underneath this curve, right, the area of an acceleration time graph is the change in velocity. And if it starts from rest, that means it's going to start here at rest. And the change in velocity is going to be equal to this area. So the area is going to be base times height because it's a rectangle. So it's 5 times 10, which is 50, which means that by the time it gets to 10 seconds, it's going to be going 50 meters per second. And we need this to increase, right? It's going to increase gradually as the rocket burns its fuel. So it'll look like that. From the graph drawn in part B, determine the velocity of the rocket after 10 seconds of travel. So that's what we just did. So 5 meters per second, because this is the change in velocity. And it's V final minus V initial is change. And the initial velocity is 0. So the final velocity must be 50. From the graph drawn in part B, determine the height of the rocket after 10 seconds. Well, we know that displacement is the area of a VT graph. And in this case, it's a triangle. So we need the 1/2 base times height, which is 1/2 times 50 times 10. So that's 500, so that's 250 meters. So you see how we use these same ideas over and over again. What's the area? What's the slope? What's the area? What's the slope? Whenever we look at a graph. Make a claim about the numerical value of the acceleration of the rocket 10.1 seconds after firing when the rocket engines have been completely shut off. The acceleration of the rocket at 10.1 seconds after it was launched is, well, now it's in free fall. So gravity is now acting on this rocket, pulling it down. So while it was accelerating from here to here, it was moving up and there was this acceleration up at 5 meters per second squared. Once it reaches max height, right, and the rockets, and at that point here, it's not max height, sorry. Once the rocket engines are off, so engines are burnt out, it then has to slow down. So you're going 50 meters per second. Before you can then fall, the engine has to turn off, the rocket has to slow to 50 meters per second, from 50 meters per second down to 0. So it's going to keep moving up, but it's going to slow down under the effects of gravity. So it's going to get to some maximum height. It's going to coast. So this whole time it's coasting and gravity is pulling it back down, causing it to slow. At maximum height, velocity is 0. That's always true. That's what the definition of max height is. You're not going up anymore, and right? But you've reached your highest point. And then once it reaches velocity 0, then it will fall downward. So the acceleration of the rocket now is due to free fall, which is 9.8 meters per second squared. That's acceleration due to gravity. And that's a constant. Use the definition of free fall to explain your reasoning. So that's what I was just saying, right? When an object is acted upon only by gravity, it is in free fall. Notice you can move up even though this is called free fall. Free fall is a strange term. It's one of those words in physics that you have to know that it doesn't just mean falling. You could be rising as well. And the value of acceleration is a constant equal to 9.8 meters per second squared. It's negative because it's down. 10.1 seconds after the rocket was launched, indicate whether the rocket's moving upward or downward. We've already kind of discussed that. Choose one piece of evidence to support your claim. So if at 10 seconds, the velocity is 50 meters per second up, then it must continue moving up but decelerate, right? But slow down until the velocity equals 0. Okay, the other thing you can do is you can look here, right? You have this constant acceleration. Now, if you're going to be under the influence of gravity, you're going to have a steeper slope, right? Double pretty much, because it's almost -10, but you're going to be decreasing. So you won't get to this y-axis for a few more seconds. Here is where velocity equals 0 again. So you'll see that it's at a later time when you finally get into the negative velocities. So it would continue down that way until it hit the ground, where all these positive velocities, these mean up. Anything down here, right, under here, would be moving downward. You can't read that. It says negative and down. So that's your justification for these questions.